There we go. So these are kind of my favorite ones. One, I always like sine and cosine because they're usually the least amount of work. So I'm just reminding myself what I'm looking for. I kind of go around my circle and find pi over 4. And then find the point that corresponds to it. So pi over 4 corresponds to root 2 over 2, comma, root 2 over 2. And then since we're looking for sine, I only care about the y of that point. So my answer is just root 2 over 2. And I'm done though. So once again, not a lot of work, it's just knowing what to look for. Ooh, excuse me. And once again, remind yourself, you can always use your notes. So just have a few written down and you should be in good shape. The main thing is that you have these 6 trig functions, or the 6 circular functions, excuse me. So you know what you need. Okay, so let's do one more kind of warm up and just see if you can remember what we were doing yesterday. So the other problem we'll do is, can you find cosine of, I'm going to make this one have a coterminal, we'll make it all sorts of fun. I think I did that one yesterday, so let me do a different one. Let's do 8 pi over 3. So I'll kind of help you with the setup and then see if you can go from there. So the first thing we always do is we go around the circle and look for 8 pi over 3, but it's not there. So that makes us sad. So in that, you're going to have to find a coterminal. Okay, it's too big. Let's make it smaller and find the angle that has the same terminal side. So you're going to take 8 pi over 3. And since it's too big, it had too many rotations, you're going to subtract 2 pi to make it smaller and in that circle. So can you take a minute? If you need a calculator, the sum up here. Remember, when you're using a calculator, don't put the pi symbol. So we don't want decimal approximations. We just want like a nice fraction so we can find it. So can you take a moment and see, I gave you some hints there to say, yeah, but could you find that coterminal and then find the cosine of that circular function? I'll give you a minute for that, bad boy. Few more seconds, we'll go over it. And I'm going to show you, we've really been doing a lot of sine and cosine. I'm trying to keep it like simple for you. I'll show you an annoying problem, and you're going to say, this is the worst, and then I'm going to show you how to make our life easier. So I feel like sometimes you don't appreciate it when I just show you the easy way, so I'll show you the hard way, and then I'll show you how we will simplify our lives. And then at the end, we'll just have a few that we're kind of trying as kind of a wrap up, because we're going to be moving on a little bit next week. We might have one little like quick assessment just before vacation, so we don't need to remember this after vacation type deal. Because next week is it. It's next week, and then we're on February vacation. Anyway. Okay, so I just grabbed my calculator, and I'm going to do 8 pi over 3. So I'm just doing 8/3. Remember, I don't put the pi in the calculator. And I'm going to subtract 2. And I'm just going to see what that comes out to. And it should come out to 2/3. So this would be 2 pi over 3. So this is the angle I'm looking at, and I want to find the point that corresponds to it is right here. It's -1/2 or 3 over 2. Now once I have that, this is a pretty easy one because cosine is equal to x. So I just take the x from this point, and that is my answer. That's it. So see if you were kind of trying those on your own to start. Does anyone have any questions before I show you like one more problem? Yeah.
You told me to use the other subtraction thing, but It gave me errors, so then I used the other one, and then it gave me it.
Let me look. I know some of these calculators are just. So what are you doing?
So,
Sure, yeah. Don't use a negative sign. If you're actually subtracting, do minus. You only do this if it's a negative number, if that makes sense. Exactly, then you would put it that as like in front, but if you just do minus 2, it should be that's why. Yeah, it gets confusing with the two symbols. Okay, so this next one is gonna make you appreciate what we do next. So I'm not gonna necessarily make you do these out, but I like to show you the torture. So then hopefully you're a little more appreciative when I show you the easy way. So we haven't really been doing a lot of cosecant, secant, cotangent. We've done like easy tangent ones, just because they can get a little bit annoying. So let's say I did this one, and I said, hey, can you find the cotangent of 11 pi over 6? You'd say, sure, I can find it. I've been doing these, these aren't that bad. So you would say, okay, 11 pi over 6, I'm gonna look up my point. It's right here in my unit circle. So it's root 3 over 2, negative a half. You say, okay, so I'm just gonna like figure out what I need, but I need x over y. Right, so it's x over y for cotangent. So in this case, it would be root 3 over 2 over negative 1/2. So that's already looking more annoying than all of our other problems. So I'm saying, oh, well, I can't leave it like that. Like, that's just gross. You can't leave fractions over fractions. When I do see a problem like this, just in general, so if you, I know you guys are probably like, I'm just never going to use this again. I know a few people are planning on college. You're probably going to have to take an entrance exam, so just as a heads up. Or if you ever even plan on taking a class here or there, those entrance exams can give you things like this, where it's like, what do I do? Just remind yourself that means divide. I always rewrite it because my brain doesn't process that. I rewrite it as root 3 over 2, and I use a division symbol instead of a division bar. This makes more sense in my head to me. Fractions over fractions are just like, oh. And then I just remind myself how to divide fractions. Some people say same, change, flipped, or we say that we multiply by the reciprocal. So you would take your first fraction, keep it the same, you would change it to multiplication, and then you would flip your second fraction. So I just get the negative at the top. You could see like, what is going on? This is like 10 million times more work than my other ones. You would be right. We would finally get to the final answer. And we would just wanna, I don't know, pack it in. So I'm not gonna make you, like we saw it, if you're writing it down, great. I'm not gonna make you do those ones. They're just annoying. But we will still have to find some values depending on what we're doing. So next week we're gonna do a little solving. Excuse me. We have a few other things, like you might just have to find the value of something. And doing the work is just annoying. So I like that, the sine, cosine I'm down with, they're pretty easy. Some of the other ones, depending what numbers you're in, they're not that bad. So what I wanted to show you quick, the people in class got it. You don't necessarily need it out right now. I'm just going to show them to you. And on Monday, cohort A, you guys will get this. We had worked with this chart in the beginning of the year. Let me put my screen down just so the people at home can kind of see what's going on. So we had this fancy chart, and you guys had actually filled one in. But let's be honest, that was like 3 months ago. Half of them are probably lost, half of them are probably crumpled. I don't even know if we ever even checked every value, so they might not have all been right. So what I decided is I'll fill in the chart for you. I'll make it all beautiful. You can see the only thing that's missing is radians. So we are going to fill that in on, I don't even know if I'm on our computer. We are going to fill this in on Monday, so that's part of our assignment. That's why I decided to do it. So we'll fill in radians because that's what we're dealing with. Now, if we think about what we just did, I did 11 pi over 6, right? I don't have the radian column yet, but if I convert radians, I did it last class, I already forgot what it was. If I convert a radian to a degree, I multiply by 180 over pi. 11 pi over 6 is 330 degrees. So we would eventually fill in 11 pi over 6 here. If I asked you for cotangents in the future, instead of doing all that workout, you would just go to the cotangent column. 11 pi over 6 would be right here, and instead of doing all that work, you would just have the answer. So remind yourself to thank me for that one next week, because that obviously saves you a million times more work. So we had done stuff with this at the beginning, and we related it to degrees. Now we're doing it and relating it to radians, so that's something we'll fill in, and that's going to save us a lot of time. Now that we know like where these answers are coming from, we can use our little shortcuts here. So that's going to be our friends next week. So if I said, hey, what's the cosine? I don't even know it. Of pi over, once again, we'll have to convert all those. Pi over 6, which is 30 degrees. You would just say, oh, it's right here. So you could look it up, but you don't have to. And so that will be delightful. On the back of that, there are some fancy identities and formulas. I just put them there for you. I don't even know if we're going to use all of them yet. But if we do in the future, I'll just remind you, hey, it's on the back of that thing, so we can kind of refer to them. So that might make your life easier. I still I'm going to be honest, I'm just planning day by day at this point, because I feel like every week something gets messed up. So we'll just kind of see where we get. And we might skip around a little bit. Like, I'm going to be honest, the next chapter's on graphing. I just think we're just not going to do that. It's torturous in a normal year, so we'll save ourselves some torture there. So for Monday, people here, just don't lose that. Cohort A, you'll be getting that. We'll be filling in basically our first thing. We'll be filling in the radian column, because that will help us out with circular functions where we're talking about radians. And then this will all be useful to us, helpful. So there you go. So that is going to be one of your best friends, because it will do a lot of the work for you, which is delightful. Okay, so here's what we're going to do. Oh shoot, I didn't mean to turn that all the way off. Let's see if this. Oh, this is like because I have the new projector. It's like actually turns back on. My other one would just stay off for like an entire day. Sorry, I wanted to circle back on. So basically, now that we have this chart on Monday, we're not gonna like kill ourselves. The projector is getting angry with me. Okay, maybe it's not gonna come back on. We'll see. So we know, the chart's gonna be a delight, but we're gonna, oh, there it is. I don't know why, just like it gets aggressively louder if you turn it back on. There you go. We're gonna try a few kind of wrap-up problems, since next week our life will be a little easier. So you can actually choose a few things. So I'm gonna say, you can either use the unit circle, or chart. I need to post it for the people at home, but to tell you the truth, the unit circle might be easier for these ones, because for the chart, you're gonna have to convert all of them and then look it up. And these ones I'm gonna give you won't be that. So it's gonna be 5 wrap-up problems. So for the people in class, in a few minutes, I'll walk around. For the people at home, you are going to be uploading it into Google Classroom, but I'll give you more instructions on that in a moment. So I leave myself a few minutes at the end, because it takes me like 15 minutes to check everyone's at this point in life. But I try to do it before class ends, because once you sign off, you kind of go into non-trig world there. All right, so here are the ones that you are going to try. Can you find the sine of pi over 3? Can you find the cosine? This one you're going to have to find a coterminal of negative 5 pi over 6. And I'll make a note, you need to find a coterminal. And you would have to find a coterminal while you have the chart either, so it's really the same amount of work. Can you find the tangent? Sorry, I know I'm blatantly in the way. I'm trying to look at this as I'm doing this. Tangent will be nice of pi. Can you find the cosecant of pi over 6? That one shouldn't be too bad, even though there's a fraction. You should be able to use your calculator for it. And the last one, let's do the secant of 0. Okay, so all of those, again, the like more complicated fraction ones, we'll just use the chart for. For now, I would just use a unit circle. To tell you the truth, it's probably gonna be less work than converting everything. And I'm going to set up the people at home in a second. Because I have way too many things going on my computers. So give me a minute at home. You're just trying them and then just wait patiently. I think it is posted for some people. Yeah, that unit circle, I mean, you can see it up on the board for the people at home, but it's also in your Google Classroom. And the people here, you should have one from yesterday. But I'm making your life easier next week, so I'm just checking that you know how to do these this week. You know, if you don't have it,